Hello everyone, this is me Arindam Sharma. I'm a faculty of Computer Science Department at Kristu Jayanti College, Autonomous, Bangalore, India. So let's talk about operating system and Linux, and the unit 2 is process management. So we have started and we have talked till deadlock. So our next topic is inter-process communication. So operating system provides facilities such as shared memory and messages passing for cooperating processes to communicate. So inter-process communication means lots of processes are there and they communicate with with each other, and messages passing for cooperating processes to communicate. So this is the basic thing about inter-process communication. Next one is process synchronization. So process synchronization is the coordination of execution of multiple processes. Please note this point here. Process synchronization is the coordination of execution of multiple processes in a multi-programming system to ensure that they access shared resources like memory in a controlled and predictable manner. So now let's understand this. See, execution of multiple processes are going on. Okay, multiple processes are currently running, but it needs to have a coordination. It needs to have a coordination. So process synchronization is the coordination of the execution of multiple processes in a multi-programming system. Multiple processes will run where? Obviously in multi-programming systems, and it ensures that they access shared resources like memory in a controlled and a predictable manner. So this is all about your process synchronization. Our next topic is process operation. Please remember, a process goes through different states before termination, and these states changes require different operations on process by an operating system. These operations include process creation, process scheduling, execution, and killing the process. So here are the key process operation. So this is the diagram, process operation. First process is created, scheduler is there. Then after scheduling, it gets executed, and once it has completed its execution, killing the process is terminated or killing the process. Okay, so this is it. Process creation in an operating system is the act of generating a new process. So how you create a new process? That is a process creation. The new process is an instance of a program that can execute independently. And our next topic is scheduling. Once a process is ready to run, it enters the ready queue. So there is this thing called ready queue. So when a process is ready to run, then it enters into the ready queue. The scheduler's job is to pick a process from this queue and start its execution. The scheduler will pick a process from the ready queue and it will start its execution. So this is it. Now execution means execution. Execution means the CPU starts working on the process. Okay, so CPU starts working on the process means it's currently running. During this time, the process might be moved to a waiting queue if it needs to perform an input-output operation, and get blocked if a higher priority process needs the CPU. Okay, so if a higher priority process suddenly comes and then it gets blocked until that higher priority process is completed. Okay, so this is your execution. Next is killing the process. After the process finishes its tasks, the operating system ends it and removes its process control block. So once it is done, the operating system ends it and removes its PCB. So this is it. PCB means process control block. Okay. The next topic is also very important. Context switching of process. The process of saving the context of one process and loading the context of another process is known as context switching. See, the definition is really easy. The process of saving the context of one process. So whatever the context it is having, it is saving it and loading the context of another process. That is called your context switching. In simple terms, it is like loading and unloading the process from the running state to the ready state. Okay, so this is it. So when does context switching happen? It happens when a higher priority process comes to a ready state. That is higher priority than the running process. So a process is currently running and somehow one more process has come there which is having some higher priority than the currently running process. Okay, so this means that only. Or maybe an interrupt occurs. User in the kernel mode. It is not necessary, though. Preemptive CPU scheduling is used. We will talk about it later on. Okay. So these 4 things are there. All right. Now let's understand context switch versus mode switch. A mode switch occurs when the CPU privilege level is changed. For example, when a system call is made or a fault occurs, the kernel works in more privileged mode than a standard user task. If an user process wants to access things that are only accessible to the kernel, a mode switch must occur. The currently executing process need not to be changed during a mode switch. A mode switch typically occurs for a process context switch to occur. Only the kernel can cause a context switch. So this is your all about context switch versus mode switch. Okay. The next topic is process scheduling algorithm. We will talk about it in the next video. Although let's simply see. This is first come first served called FCFS. Shortest job first, SJF, and round robin. These are really important. And priority scheduling, multi-level queue. These all things are there. We will talk about it in our next video.